This video is going to introduce the psf-fpp-client. This allows developers to download and pin files on our IPFS network. So psf-fpp stands for Permissionless Software Foundation File Pinning Protocol. So this continues a series of videos that I created that are up on my YouTube channel. So the first video was an introduction to the UI demo, which can be found at upload.psfoundation.info. This allows you to upload single files to our IPFS file pinning network. And then there was a second video that walked through the infrastructure and the system diagram. So this third video is for developers and PSF members who want to integrate the psf-fpp into their own software to begin uploading and pinning files to our IPFS network and the ability to download those files into their own applications. So before I get into this, if you need help, the place to get it is our PSF Telegram channel. And you can find a link to the Telegram channel at psfoundation.info. That's the documentation for our organization, the Permissionless Software Foundation. If you scroll down to the bottom, there is a link to our Telegram channel right here in the footer. And so you can go there to get help. So just a quick recap, you can use upload.psfoundation.info to upload single files to our file pinning network. And as I just showed, there's already those two demo videos on YouTube. So here's what I'm going to be covering in this presentation. I'm going to show how to install the psf-fpp-client and run it, and then install the psf-bch-wallet and fund it. So the psf-fpp-client is a small REST API server, web server, that allows you to make REST API calls to it in order to download and upload files. It's essentially an IPFS node, and it reaches out, finds, and connects to all the other nodes on the PSF network. And then psf-bch-wallet is our command line wallet. It's a fully functional Bitcoin Cash wallet that supports SLP tokens, and it has a bunch of other commands for interacting with PSF infrastructure and software. So that's what I'm going to demo. So we'll install those, set them up, get them talking to one another. Then I'll show this latest feature, which is a REST API endpoint here that shows the latest pinned content on our IPFS network. This will eventually be a dashboard at upload.psfoundation.info, but right now it's just here. I'll show that here in a second. And then I'm going to go through a few different use cases. So I'll show how to download a file from our IPFS network. I'll show how to upload a file to our IPFS network, which is just adding a file to the IPFS node. And then I'll show how to pin a file, which actually leverages this upload file. So that's why I have this not needed here. I'll get into more details about that. And then I will review the psf-fpp npm library, which a lot of the software is built on top of. So let me go ahead and just dive in here. I've got a Ubuntu 18 virtual machine running here. This is what I'm going to be running for the demo. So I'm essentially simulating a brand new computer that's never seen this software before. So that'll be the same situation that you're in when you're watching this video. As always, all PSF software targets the Ubuntu operating system. You can run it on other operating systems, but all the documentation and videos assume that you're running on Ubuntu. If you want to try a different operating system, you might get a different experience. So just that little caveat there. Okay, so I'm going to log into my virtual machine. It's running on port 2222. and I'm running node 16 and npm 8. I have tested this software with node 20 and 18 and it works fine. I just can't run those on this older, or I guess it's running 20, but for some reason I had trouble installing those versions, so I'm running 16. But if you're running the latest version, which is 20 as of this recording, it'll work fine. So I'll just get rid of this old project here. And the code is, as always, on GitHub in the Permissionless Software Foundation GitHub group. And this is the psff-pp-client. This is forked from IPFS Service Provider, so that's an interesting repository to look into. A lot of our software is forked from that boilerplate. So I'll just start by cloning that repository. I'll make this bigger. There we go. Make both of these bigger so that they're easier to see. Okay, and so I can go in here and install dependencies. I'll do that, and then I'll do the same thing over here. I'll log into the VM and I will clone our psf-bch-wallet command line wallet. So this tab is the psff-pp-client, and this tab is going to be the psf-bch-wallet. So I'll just let the cloning finish, and then I'm going to install dependencies with npm install in both of these directories. Okay, so all I've done is cloned the repository and ran npm install in both these directories. So now my work folder has these two projects, and they now have their npm dependencies installed. Okay, so let's run this psff-pp client. So I'll clear this, and you can just run it with npm start. This uses all the default config variables. There are a number of config variables that you can set to change the behavior of this, but the default value is, you can see it spinning up, and it is finding all the different nodes to connect to. It's connecting to these two bootstrap nodes. The logging is a little verbose, so you can see it's already connecting to different peer nodes that it's found. This takes about 5 minutes for it to fully find and connect to all the other IPFS nodes on our network. So just let this run in the background. It's a pretty lightweight app, so you can let it run in the background on your computer like a Bitcoin node. And it won't use much CPU or memory or bandwidth. It'll just sit there and try and stay connected to all the other nodes in the network. So we'll just let that run while we fund this wallet. So everything is run with this bin run command, and help is probably the best command to run. This will list all the commands that are available, and we're going to focus on these new psff-pp commands. But first we need to create a wallet and fund it with Bitcoin Cash and PSF tokens. So I'm going to go wallet create, and I'm just going to call this test, and then I'm going to list the addresses for that wallet. So now that I have an address, I'm going to fund this with Bitcoin Cash and PSF tokens, and I already have a wallet here that has both of those. If you Bitcoin Cash can be attained on every exchange and every decentralized exchange, and then PSF tokens can be obtained at psfoundation.cash make sure you're using this command line wallet. You have to have a token aware wallet like our command line wallet or our web wallet at wallet.fullstack.cash. And you can send a little bit of Bitcoin Cash, like not more than $1, to this address, and it will send you PSF tokens back. And so I've covered this in other videos. That's why I'm going really fast. But I've already got some in here. So I'm going to copy this address, and I'll send it 50 cents worth of Bitcoin Cash. And then I'll go over my tokens, and I'll send it one PSF token. All right. So now if I go wallet balances, I'll just check the balance of the wallet, make sure that everything transferred. So there we go. I got some Satoshis, and I got one PSF token. So I'm good to go. And so there is this new IPFS files directory, and that's where you need to, when you download a file, that's where it's going to appear, and when you upload files, they need to be in this directory. So I already have this landscape picture here that I'm going to move into the IPFS files directory. So this is the file that we're going to upload when we get to that point. But first, let's explore downloading. So we've installed the client and we're running it. We installed the wallet and we funded it. So one of the new features that's not fully developed yet is this new REST API endpoint that shows the latest 20 items pinned to our IPFS file network. So this IPFS this IP address is one of the file pin servers on the network, and it's operating on port 5031. And I'm making a call to this IPFS pins endpoint, and it's giving me back this JSON. And I'm using Firefox here, and it's automatically interpreting that JSON and printing it out so it looks real nice. So if you use a different browser, you might get a different experience. But I can see all these items, so 1, 2, 3, 4, 5, and so on. It's an array. And it's saying that here's the file name, here is the content ID or CID, which is how content on the IPFS network is tracked. It is a valid claim, and it has been pinned, and these many tokens, so there's all this other kinds of information. But what we need to download it is the CID. That's how everything on the IPFS network works. And so let's check out this download command. So you give it a CID, which we just grabbed from that page, and a file name, which is the name that the downloaded file is going to get renamed to, because the file names are not preserved on the IPFS network. So you have to tell it sort of what the file name and extension is. You have to know that some other way. So that's why that information is retained in the protocol. So this command line wallet is now making a REST API call to the client, which is an IPFS node and is connected to the network to download the file. So it looks like it succeeded. And if I look in there, this landscape 2 was just downloaded, and we have that picture. I could open it in a web browser if I wanted. So this is how you can find content on our PIN network, and you can download that content from the PIN network. And so, of course, this could be, the whole point of this is you would integrate this code into your own application. So psf-bch-wallet is, beyond being a command line wallet, it's also an excellent way to share code. Each command is like a little JavaScript file, and you can go look at the code there if you want to see how this download process works and integrate it into your own application. So okay, let's now check out the upload command. So I put in the outline that it's not needed, and that's true. So this upload command is actually used by the pin command that we will use next. So you don't actually need to use this command. All it's doing is it's telling the psff-pp-client to, I'm just going to call it the client from now on. It's telling the client to, hey, here's a file, hash it and add it as an IPFS and give me the CID back. But only this one client on the network has that file. None of the other nodes on the network are going to pin the file, but it is there and available, and all the other IPFS nodes can sort of download that file if they want to, but it doesn't actually instruct them to pin it. That's what the pinning command does. And so it uses this upload command. You don't need to do it. It does it automatically. But I'm just, for the sake of thoroughness, I want to show you how it works. So if we go psf-pp upload, and we give it that file name of, let's see, landscape 3, which is a new file that it hasn't seen. Yeah, there's no out. Oh, that's weird that it's no output. But you can see here in the client that it made the REST API call and it returned a CID. So that's just the upload command, just so you know. So now let's look at the pin command. So here you give it a file name to upload and pin, and then the name of a wallet to pay for the pinning service. So let's do that right now. So we're going to use our test wallet, and we're going to use that landscape 3 JPEG. So let me just get some empty lines here so we can see what's going on. So it's updating the balance of the wallet. It's searching the blockchain for the write price. That's the cost of writing, and that's set by the minting council, the PSF minting council. So this data is stored on the Bitcoin Cash blockchain, so it's just looking that data up right now. And this step is time consuming, and in this case it looks it up every time. But if you were to integrate this into an application, you would cache this information so that you only need to do it, once a day or once a week. The price doesn't change very often, but then you would cache it, say, in a local database or a local JSON file, and then you can just look up this write information, every once in a while, rather than every time. Just waiting for it to, once it finishes, look, there we go. Okay, so it found the current cost of writing. It uploaded the file and got a CID, and now it is burning that amount of PSF tokens to pay for the write. There's that upload command. That's how it got the CID. Okay, so it burned it, and it created a proof of burn transaction. That's the transaction ID. I could look this up on the Blockchair Block Explorer if I wanted to see that transaction. And then it also generated a claim transaction ID. And so it's out there on the network. So now this node has that file from running the upload command internally, and it's issued the proof of burn transaction and the claim transaction on the Bitcoin Cash blockchain. So all the other nodes that are running the pinning service will pick up on those transactions and download the file from this node, and that'll all happen automatically. So if we go back to this endpoint, and the last entry was landscape 2, let's see. Okay, now our file landscape 3 is, this is like a whole nother computer that we're talking to that has no direct connection to our node except through the IPFS network. But it did find the file, downloaded it via the CID, determined that it was a valid claim, and the data is now pinned and available on the IPFS pinning network for the next year. So that's how it works. That's a demo. You can do the same thing, go through the motions, make sure you can do this, and then the code, if you want to start integrating this into your own app, is you can just look at the code that we ran. So let's do this actually. First I want to talk about the psf-fpp-npm library. So let's go to npm and go to psf-pp. So a lot of this code ran on top of, that we just ran on top of this library. So this is how you instantiate it. It's using the minimal SLP wallet here, which is the same thing as our code just ran. And it's got a get write price, so you can call this function to get the current price to write data to the network for 1 megabyte. And so you can write up to 100 megabytes. So if you have multiple megabytes, just multiply the number of megabytes by this number, and that's the number of PSF tokens you need to burn in order to pay for the pinning service. And then, as I've said before in other videos, the minimum amount is 1 megabyte. So even if in this case we sent an image that was 0.07 megabytes, but we still had to burn the same amount of PSF tokens for 1 megabyte. That's the minimum. And then there's this create pin claim API, and so you give it a CID, the file name, and the size of the file, and you pass that object into this create pin claim API, and it will do the heavy lifting and return a proof of burn transaction and a claim transaction, just like we saw here in the command. So that's the library. There's also going to be a validate claim API that I'll add to this library that will just sort of, you can give it a claim, a pin claim transaction, and it will validate it. So look forward to that. That'll be added. We don't really need it for downloading, uploading. That's something that the IPFS pinning network uses. So that's that, and then as I said, the psf-bch-wallet is, besides being a functional command line wallet, it's also a great prototyping tool and a way to share code. So if you go into this commands folder, you can actually dive into these commands. So for example, this pin command that we just ran, you can see this is a standalone JavaScript application, so you can see how we do it. So at the top there's this run command. It locates the file from the wallet file that we're going to use to pay for this, and then it calls this pin file function, and this is where all the heavy lifting happens. So it instantiates the wallet, it gets the size of the file, it instantiates the psf-fpp library that I just showed. It calculates the cost in PSF tokens by multiplying the write price by, or actually it just gets the default write price for 1 megabyte. Uploads the file to the IPFS node leveraging the upload file command, and then it generates a pin claim by using that API in the psf-fpp-npm library I just showed, and so that does all the heavy lifting, and that does the actual paying and pinning of the file. So hopefully this gives a basic, again, this video was intended for developers and PSF members who want to start integrating this technology into their own tokens, or anything where you'd want to pin content to the IPFS network. That's a very broad and common use case. So hopefully that'll help you do that. And again, if you have questions or need help, or you find this technology interesting, please come to the PSF Telegram channel.